Okay, it is not always convenient to find the area between curves vertically. We saw an example of that yesterday, didn't we? At the very end of class, that example that we did, we had to do what with our area? We had to separate it because the function on the bottom changed. Okay? Now sometimes it could be just unavoidable. Sometimes it could be more convenient to find the area horizontally. Can I do that?
No.
Yes. Okay, so finding the area between curves vertically, we took top function minus bottom function. Have a conversation at your table. How are things going to change when we go horizontally? Not just top minus bottom, but what else is going to change about maybe our integral? Okay, let's check. Okay, Amy, how might things be different?
It'd be like right minus left, or you'd have to do it in respect to y.
Oh, double whammy right here. Okay, she said right minus left. And maybe we'll have to go with respect to y. Okay. Yeah, I kind of gave that away, didn't I? I wasn't very sneaky with that one. Okay, so very quickly. All right, imagine drawing horizontal or vertical rectangles here. This rectangle has a different top and bottom than this rectangle, then this rectangle, then this. Oh my gosh, this is absolutely ridiculous, right? Instead, we can draw rectangles that are horizontal, which means their thickness would be dy, infinitely small along the y-axis, right? And as Amy brought up from their pod 3 discussion, we are going to have right minus left in terms of y. So we're always doing a more positive area minus the lesser positive area. Okay, so now we're kind of at a point where we're going to do some examples here, but then eventually you're going to have to decide for yourself, is it going to be best to draw horizontal or vertical rectangles? Should I use X or should I use Y? Now let's think about when we set this up. Do you notice how we have f of y and g of y? That means our functions need to be in terms of y. So we would need like x equals y plus 3, or x equals y squared, things like that. We're going to have y's inside of there, which means we would need to solve for x if it's possible. Okay? So we're going to go back to our example from yesterday. This is the example that we did at the end of class. The region bounded by y, x equals y squared and y equals x plus minus 2. Go ahead and rewrite that down. Pretty full, sorry. And all of our movie night stuff. Recycled in. Oh, can we not do that? Oh, I'm sorry. Thank you. This is the same one from yesterday, right?
Yes.
Okay. Now, here's our area. Okay? And I'll do like I did yesterday. I'll do like I did yesterday where I'll highlight the area so you can really see what's going on here. Okay. Now, we are going to draw a horizontal rectangle with thickness dy, and you can see now that the function on the right is consistent, the function on the left is consistent. Because now that we keep it as x equals y squared, it's one function. Yesterday we had it as, well, I guess I shouldn't say function because it's not a function, it's one equation. Yesterday we had to split it into two different equations, y equals radical x, y equals negative radical x. But if we leave it as x equals y squared, it's 1. Okay? Should we keep this as y equals x minus 2? No. Okay, Michael, you said no. What do we have to rewrite it as?
X equals y plus 2.
Yeah, x equals y plus 2. We have to solve for x so that our function can be, or excuse me, our equation can be in terms of y. Okay? Now, are we still going from, what did we do yesterday? We did like 0 to 1 and 1 to 4. Is that what we're doing today?
No.
No, we have to go in terms of y. So we need to think about where is our very lowest and where is our very highest point? Where are these rectangles falling? So since we're in terms of y, we need to think about our y values. So what is this y value right here? Okay, so that y value is -1. What is this y value up here? 2. So we need to go from -1 to 2 of our right function, y plus 2, minus our left function, y squared. Now we only have one integral to solve. That's nice, isn't it? That's really nice. I really don't see the need to practice the integration because I know you don't have to do it. So we're really just going to focus on setting up today. Does that sound all right with everyone? Okay. Okay, how many of you would prefer yesterday's way? Okay. Now, it doesn't matter which way you do it unless I specify do it in terms of y. Okay, and I could do that. I could say find the area in terms of y, or I could say find the area, and you have to decide what you need to do. Okay, let's look at another example. This one, your choice is going to be a little bit clearer. Okay, biggest challenge might be getting this drawn. Y equals -y squared plus, excuse me, x equals -y squared plus 10, and x equals y minus 2, the quantity squared. Both of these equations are what? Parabolas, but they're opening
Sideways.
Sideways. Thank you. How do we know which way they open? First.
If it's negative, it's gonna open
Yeah. Yeah, I like the way you described that. If it's negative, it's going to open toward negative infinity, to the left. Okay, if it's positive, it's going to open to the right. So, negative y squared, Trevor says, opening to the left, plus 10. Where does that move?
to the left. It's
They have like 3 different directions going
no,
on.
no, to the right.
Okay, talk about it with your pod. Maybe like try a value and then maybe it'll help you out.
Yeah. But it's in terms of y. But it would be down
Close to the left and down to the y, to the right and turn to the
it
left.
would be down 10 actually.
Okay. Let's think about this. If it were y equals negative x squared plus 10, which way would it go?
Up 10.
Okay. X is now the dependent variable of y. Marcus, you are correct. It is going to go to the right 10. Okay? We're going up, but in terms of the other axis, right? Because now x is the dependent variable of y. So it is going to go to the right 10. Okay? X equals y minus 2 the quantity squared. I'm really going to read for a little bit. Think about if the x's and y's were changed, which way would it go? Okay, if it was y equal x minus 2 squared, that would be a right shift. So now let's change x and y. Instead of a right shift, it's going to be an upshift. Okay, if you don't know, plug in some numbers until you get a shape. Okay, or they may give you like x equals y squared minus 2y. All right, how about plus 2y? Kind of like 19, right? If you had something like this, you could find the zeros and it would be really nice, right? Okay. All right. What kind of rectangles do we want to draw in there? Neither. Okay, we want horizontal. Okay? The function on the right is, and maybe I should put it in red here. The function on the right is always x equals negative y squared plus 10. The function on the left is always x equals y minus 2 squared. Okay? Only thing we have to determine are the points of intersection. Joe? Negative 1 and 1? I don't think this one can be 1. Because our vertex is already at 2. Okay? I would say with this one, I mean, some of our minds are still kind of like, is this really what the graph looks like, right? This would be a one that maybe doing algebra would be a smart idea. Wouldn't you? Agreed? Okay. Might feel nice to do some algebra. Negative y squared plus 10 equals y minus 2 the quantity squared. they don't.
No, I meant the white squares.
But they don't. Because we have to add it over. Because they're on opposite sides, right, Trevor? Right, Trevor? Don't laugh.
Yeah.
There's no laughing at Trevor. You're laughing at me?
I was laughing at his face.
Well, that doesn't sound
No, I just
sir.
he made this face when you do that. Never mind.
Leave this classroom now. I'm good.
I think they're laughing because they love you, Trevor.
No, they hate it.
I think Trevor's gonna need a group hug at the end of this.
No.
All right. Suggestions? Okay. I'm just gonna divide by 2, is that okay? Since there's 0 on the other side, we can do that. And then this factors to y minus 3, y plus 1. Okay? So like Joe said -1 and 3, but some of us needed some verification on that, right? For sure. For sure. Okay? So our integral. -1 to 3 we decided. Our right function is -y squared plus 10 minus our left function, y minus 2, this quantity squared, dy. This is one that, in my opinion, is pretty tedious to do by hand, okay? Which is why I am having you do a majority of your assignment with the Math 9 command. Okay, I think that, well, I hope that you appreciate that. But, I mean, I know you can integrate that, but plugging in the 3 and the -1 and all the fractions, like, that's just tedious. What I'm more concerned about is the setup of the problem, the graph of the problem. Trevor?
How do you do it, like, in terms of y? Just, like, turn it into...
So I would just use X in your calculator. Just type everything in using the X key, and it'll still give you the same value. Okay, does that make sense? That's a good question, and I always forget about that confusion. But you can use X in your calculator, and it's still going to give you the same number. Yes?
When you set them equal to each other, isn't that result already what you're going to get when you combine them? Can you just use that instead? The 2y squared minus 4y minus 6? I think you did it the other way around. Like if you... Because like you have one equation equals another equation, so you subtracted the other equation over.
Yeah?
So you have the two equations combined. You could just take the integral of 2y squared minus 4y minus 6.
Well, no.
It'd have to be, you'd have to switch the signs. It'd have to be
Yeah.
2y squared minus 4y.
But technically, yeah, you're right. Yes.
Okay.
I see what you're saying. I see what you're saying. Yeah. And not all the time do we, like, sometimes our graphs, we're not going to need to do the algebra, but yeah, I see what you're saying. Okay, now, another thing. If you're not going to use the algebra to find the points of intersection, how can you verify that they are actually the true points of intersection?
Second power 5.
Let's assume we don't have our calculator.
Second power 5.
You choose between two different points and gives you, you don't have the calculator.
What if you don't have a calculator?
Yes.
If I plug in -1, I get 9. If I plug in -1, I get 9. They're the same. That's good. If I plug in 3, I get 1. If I plug in 3, I get 1. They're the same. It's an intersection point. It's like I blew your mind, but that would... Oh.
Something is something.
Okay, I'll read this to you. Find the number b such that the line y equals b divides the region bounded by the curves y equals x squared and y equals 4 into two regions with equal area. What? Right? Okay. We are looking for y equals b that divides these regions into two equal areas. Let's first just draw a picture. Do we know what y equals x squared looks like? And we know what y equals 4 looks like. And I'm actually going to get rid of this right now. I don't want you set on. I want the line y equals b to where this area right here is the same exact area as this area right here. Take a moment to brainstorm at your pod what might we need to do. Which means talk to each other.
Y equals a number and that divides.
Yeah.
Y equals the area of
Like, I don't even want to know why are you operating at first? You're so okay.
I don't know.
Okay. Who has an idea? Okay. We know Jackson has an idea. I just want to know, is anybody besides Jackson have an idea that they're really good about? Part one, what did you discuss?
You'd have to like divide something by 2 and like plug that in.
Okay. Okay, so you're saying finding the entire area divided by 2, and you know that that's what each of those sections need to equal? Okay. Okay. Part 5? Anything?
Kind of the same thing. Find the area, divide by 2, and then
Okay. All right. Jackson?
I was thinking you could use like right and left equations to set the two areas equal to each other, like the green area and the yellow area. So you'd have to write the parabola as x equals the square root of y and x equals the negative square root of y. And then you could set the integral from 0 to b of right minus left equal to the integral from b to 4 of right minus left.
Okay. So we have two ideas here. Jackson is saying let's set the green area equal to the yellow area. And we've had a couple people over here say let's find all of the area, split it in half, and then set the green area equal to it, or the yellow area. Okay? Are both ways going to get you the answer? Yes. Okay. Which one is it? I'm not sure it's going to matter. You're still having to evaluate two integrals, the way that you described it to me. The way you guys described it to me, we have to find the big integral, cut that number in half, and then set it equal to another integral and find that. Jackson's saying set two integrals equal to each other. There's still two integrals to solve. Okay? Now, since today has been all about right minus left, I'm going to go ahead and go Jackson's way since that's the skill that we've been working on today. Okay? I'm going to draw in my rectangles here. So, basically, this green equation is x equals square root of y, and the blue equation is x equals negative radical y. So, what Jackson is saying is we can take the integral from 0 to b, right, our height is 0 to b, of right minus left, radical y minus negative radical y, dy, equals the integral from b to 4 of right minus left. Okay. So we have this integral from 0 to b equals the integral from b to 4. Okay, 2y to the 1/2. Antiderivative of 2y to the 1/2. Antiderivative of 2y to the 1/2. CJ, what would that be?
4/3 y to the 3/2.
Okay, now we have to evaluate these two integrals. 4/3 b to the 3/2 minus 0 equals 4/3 4 to the 3/2 minus 4/3 b to the 3/2. Trevor, are you getting a little worried? That's not too much. We can do it. I have faith in you. Okay, let's talk about 4 to the 3/2. How are we doing on time here? Okay. Square root of 4 is 2, cubed is 8 times 4/3. Let's just keep it as a improper fraction. 32/3. It'll be easier when we get to step here. Then I can add this over to combine with this 4/3 to the b to the 3/2. So then we have 8/3. Yep, very good. Then we can divide 8/3 over to give us 4.
Yeah.
To get rid of the 3/2 power, we can take the 2/3 power to both sides, and b equals 4 to the 2/3 power. Okay? Maybe a little bit more painful than the other problems that we did today, but nothing that you cannot handle. I will warn you, you will have a problem like this in your homework this evening. Okay? Do what you can. Do I expect everybody to get it 100%? Probably not, but I need you to try. Okay, once again, tonight you have 2 problems you need to do without a calculator. Everything else,
And label,
what?
and label.
Yes, they are labeled. In this entire chapter, anything with a calculator will be labeled. Or without a calculator.
Is it B, is it 4 to 2/3?
Yes, it is. It is 4 to the 2/3. Okay. All right, so do your homework. Do your homework. Do your homework. And drive safely tomorrow. It's supposed to snow in the morning. I hate to say it.